Okay, for question number 7, the number of cars caught speeding on a certain length of motorway is 7.2 per day on average. Speed cameras are introduced and the results shown in the following table are those from a random selection of 40 days after this. This is your distribution and you need to calculate an unbiased estimate of the population mean. Unbiased estimate of the population mean is going to be, let's take a look. That's going to be the summation of x divided by n. What is the summation of x? 4 times 5, 5 times 7, 6 times 4, 8, and then you add all of that. And then when you do it, you're going to come up to 261 divided by 40. Number of days is 40. So the to three significant figures, we're looking at 6.53. Oh dear, handwriting is getting bad here. 6.53 to three significant figures. So this is the answer to the first part of the question. For the second part, okay, we need to find, the first part again, the variance, an unbiased estimate of the population variance. Now that's going to be, we're going to have to use the formula. Which formula we're going to be using is n over n minus 1 times the summation of x squared divided by n minus the mean to the square. Okay, now I hope you get this. Yeah, here we go. So over here you're going to have to square these numbers: 25, 36, 49, pardon my handwriting, 64, 81, 100. You square each of these and then you multiply by the variables. Here we go. And then you add up. And when you do that, you're going to come up with the summation. But first of all, n over n minus 1 is, n is 40 over n minus 1 is 39. 40 minus 1, 39. Into this here is going to be 1815. That's the summation of x squared. That is when you take the sum of all these products and then you divide by 40 and you minus the mean. The mean that you just calculated, 6.525 to the square. Do that in your calculator. You should be able to get 2.87 and something. So, but to three significant figures, we're looking at 2.87. So that's an unbiased estimate of your population mean. First part done. For the second part of the question, taking the null hypothesis HO to be mu is equal to 7.2, test at 5% level whether there is evidence that the introduction of speed cameras has resulted in a reduction in the number of cars caught speeding. Now at 5% we're looking for a decrease in the number of cars caught speeding. Therefore it's going to be on the left hand side of the graph, 0.05%. If you work this out, you're going to check that the z value of this is going to be equal to the inverse pi of 0.95, which gives you from your table, that should give you, we're going to look at the negative here, negative 1.645. Over here we're going to need to test at 5% significant level. This is 40. That means it's greater or equal to 30. Therefore it's a normal distribution. So for a normal distribution we're going to be using the formula observed means minus the mean population mean over the standard deviation divided by the root of n. In that case we're looking for the mean, which we calculated was 6.53. So we're going to say 6.525. That was what we got from our calculator, minus the population mean 7.2 over the standard deviation. Alright, and the standard deviation is, we got the square root of the variance. Alright, and that was the population variance. So we're going to look at the square root of then 2.87, and from our calculator we reached with all that figure there, divided by 40, which comes up to, when you work it out, 2.1519 and so on. Now this is basically less than minus, so this we're looking at, this thing is less than minus 1.645. That means if it's less, it's going to fall within that area here, within that region here. If it falls within the critical region or the rejection region, therefore we accept we reject the null hypothesis and we accept the alternative hypothesis. The alternative hypothesis is that the mean should be less than 7.2 cars caught speeding. Therefore we're looking at, yes, there has been a reduction in the number of cars caught speeding. Reduction in number of cars caught speeding. Done. Yes. So this is the second part of the question. Now for the last part of the question, part 3, state what is meant by a type 1 error in words relating to the context of the test in part 2. Now let us take a look at what a type 1 error is. First of all, what we know is that a type 1 error is meant to be when we are rejecting the null hypothesis given that it is true. So a type 1 error, in other words, we are accepting the alternate hypothesis when it's false. So we are accepting that there has been a reduction. Remember, the alternate hypothesis is H1, the mean should be less than 7.2. Alright, so let me just write this correctly here. Alternate hypothesis. The reason I'm writing this is just to get it clear. So we are going to accept this because this is what is meant by type 1 error, accepting the alternative hypothesis. And what is the alternative hypothesis? It is when the mean is less than 7.2. So it is when the number of cars caught speeding on the motorway has reduced. So we are saying that there has been a reduction, okay, in number of cars caught speeding when there hasn't. Caught speeding when there hasn't. In a type 1 error, we're looking at the one-tail situation because we're looking at reduction. Okay, so less on this side of the graph. A type 1 error will be always in this area here. So this is should be our mean, 7.2, and that's the type 1 error is here, making it clear where the region will represent a type 1. And of course you can write HO here and H1 inside here. So this would be the last part of the question. Take care.